This video is for General Chemistry 1, Chem 115 at St. Charles Community College, part of Chapter 2, which is the beginning of naming, Part 1, naming cations and anions. We will begin naming compounds in class, so we're just starting the naming by looking at just naming the individual ions. But an overview, in this class we're going to learn to name inorganic compounds. Nomenclature is the fancy way of saying naming, so we're going to learn chemical nomenclature, naming compounds. Now, there are actually two categories. There's organic compounds and there's inorganic compounds. Well, we're learning to name the inorganic compounds, which means we're going to learn to name ionic compounds, molecular compounds, and acids. We've talked a little bit about ionic and a little bit about molecular compounds. We'll talk about acids later. Organic compounds, the other category, that's reserved for organic chemistry. Our textbook does go a little bit into it, but you're not going to be held to naming organic compounds this semester at all. So before we can get to the compounds, though, before we can name ionic compounds, we have to learn how to name the individual ions, so the cations and the anions. So that's what we're going to do in this video. So we're going to start by naming the positively charged ions, which are cations. Okay, well, the cations, the monatomic ions, the one atom ions, we've learned that group 1 on the periodic table is a +1, group 2 on the periodic table is +2, and group 13 on the periodic table is +3. So if we're naming one of those ions, so two examples are the Na and the Mg. Na is in group 1, Mg is in group 2. When we name them, it's super easy. We just say the name of the element followed by the word ion. Nowhere in its name do you have to tell me its charge, because sodium ion, sodium's in group 1. We know everything in group 1 is a +1. Magnesium ion, magnesium's in group 2. Everything in group 2 is a +2. So magnesium ion, we know that it's a +2 because magnesium is in group 2. That's how we name the cations that are in group 1, group 2, or group 13. If we run into a cation, so a positively charged thing, that it lives somewhere else on the periodic table, so like in that transition metal section, or in group 14, we have to be more clear on its name because, like, for example, iron. If you look at iron on the periodic table, it's not one of the groups that we put a charge above, so you would not know if I just said, oh, it's iron ion. Like, okay, so it's Fe with a charge. You wouldn't know what charge. So when we're naming those things that are positively charged, not in group 1, not in group 2, not in group 13, the element lives somewhere else on the periodic table, we have to add to its name parentheses with the Roman numeral inside of the parentheses telling you what the number on the charge is. So example, Fe2+, iron with a 2+ charge. So its name is iron 2 ion. Fe3+, so it's iron 3 ion. If we didn't have those parentheses in the Roman numerals, those would have the same name, but they would not be the same thing. So that's why we have to have that distinction. It would be wrong if you called Na+ sodium 1 ion. That is incorrect. We only do the parentheses when we have to. And we have to when the element is a transition metal or from group 14. Okay? This might seem horrible. Trust me, it's not as bad as it used to be. You used to have to memorize every one of the elements that had more than one charge, learn its Latin name, and then name it based on its Latin name and the memorized charge. So I'll show you an example here in a second, but putting Roman numerals is really fine. So the transition metals, those are the middle block group of elements, group 13 through, or sorry, group 3, group 12, everything in between group 3 and group 12, and group 14. And they have more than one charge. Every element in there has more than one charge with 3 exceptions, and those 3 exceptions you are going to have to memorize. The first one is silver. Silver, Ag, always has a +1 charge, so its name is silver ion. Cadmium, Cd, always has a 2+ charge, so its name is just cadmium ion. And zinc, Zn, always has a 2+ charge, so its name is just zinc ion. If you look on the handout that I gave you guys that has on one side the polyatomic ions, the bottom of that, those 3 are listed as, I think, weird transition metal ions, I think is how I very classily named that. So you're going to have to memorize those 3 things. Okay. So this is the old school way of naming the transition metals. You are not being held accountable for this, but if you Google it, sometimes you're going to run across these. Plus, I want to make sure you realize that your life could be so much worse with naming things than it is. So we used to have to memorize the Latin name plus every charge that was possible. So if like iron could either be a +2 or +3. That's the example from the last slide. So of those two, +3 is the more positive, it's a larger charge, and +2 is the more negative, it's the smaller charge. So we would have had to have memorized the Latin name of iron and added OUS to the end for the smaller charge and IC on the end of the bigger charge. Yeah, this is way worse than writing 2 in parentheses and 3 in parentheses using Roman numerals. So we're going to call Fe2 plus iron 2 ion and Fe3 plus iron 3 ion. And I'm just showing you what it could be. Okay. Now in the polyatomic ion table, there's only one that you have to memorize, and it's ammonium. Just so you know, every polyatomic ion that has a positive charge ends in -ium. You just don't have to memorize any more than that. So for NH4+, you just need to memorize it's an ammonium. And for the polyatomic ions, you just have to memorize those buddies. Like, you just need to learn their name. They've already been named. We just have to memorize them. So this is just a table from our textbook with some common cations. On this table, so if you look over here, CO2 plus, cobalt 2 ion, or it says cobaltous ion, that's that weird Latin version. You don't have to know those. You need to know the parentheses ones, and you don't have to, you're not like memorizing these. You have to know Ni stands for nickel, and it's got a 2 plus, so you put a 2 there. Okay. So now let's switch over to the anions, the negative charges. So the negative charges, well, on the periodic table, we have group 15, group 16, and group 17. Group 15, those had a -3 charge. Group 16, 2 minus. Group 17, -1. So the way we're going to handle naming those, we are not going to use parentheses. We're not going to put their charge because we know group 15, -3. Group 16, -2. Group 17, -1. So instead, we're going to take the name of the element, drop off the ending. So like oxygen, we drop off the ending and replace it with "ide." Excuse me. So Cl minus is chlorine. We drop off the ending, the ine, I-N-E, and replace it with "ide." Cl minus is chloride. Most of these are pretty common like this. These 3 that I actually put in the box are kind of the weird ones because O-2, O is oxygen. So if you drop out the ending, you might be like, oh, what's the ending? Is it the N? And then it would be oxygenide. Okay, that sounds weird. We're not calling it oxygenide, it's oxide. So we dropped off a lot of it. So nitrogen, N3 minus. Drop off the ending. Again, you might think, well, it's nitrogide. Also weird. Nitride is what we're going with. S is sulfur. So dropping off the ending is just the UR, so it's sulfide. That one's not super weird, but it's different than maybe what you'd expect. The good news is there's not very many of these, so you're going to see them over and over and over again because there aren't very many -3, -2, and -1 charged things. Most of the polyatomic ions you have to memorize have negative charges. 3 of those polyatomic ions you have to memorize. Their names end in "ide", just like the monatomic anions. Well, you're just memorizing these, so you just have to learn that, okay? So all the rest of the anions are coming from the polyatomic ion table. Again, look at the handout that I gave you and memorize it, basically. The handout is also in Canvas, but other than the 3 that were on the last slide, pretty much all the rest of them end in ATE or ITE. So what these next couple slides are just me going through some potentially helpful hints for you to memorize the polyatomic ions. If what I'm going to tell you here is not helpful, then make flashcards and put the symbol on one side and the name on the other and just straight up memorizing them. Okay, so all that I'm doing here is trying to be helpful. So you're going to notice there's a lot of 8s and ites, like the first 2 things on the table are nitrate, NO3 minus, and nitrite, NO2 minus. There's a pattern here. If there's an 8 and an ite, the 8 version always has 1 more oxygen than the ite version. So nitrate has 3 oxygens, nitrite has 2 oxygens. Another one of these patterns, sulfate has 4 oxygens and sulfite has 3 oxygens. So there's our visual. This works for more than just these 2. I just chose 2 of them. There's a phosphate and a phosphite. There's a chlorate and there's a chlorite. There's all kinds of this. Notice that just because it's an 8, like nitrate has 3 oxygens, sulfate has 4 oxygens. So the pattern isn't between nitrate and sulfate. Nope, that's not the pattern. The pattern is between nitrate and nitrite. So the 8 and the ite version. When it goes down to the ite version, there's 1 less oxygen. I know it sounds like we're speaking another language, and basically naming chemical compounds is like speaking another language. Okay, so I'm still convinced chemistry should be a science credit, a math credit, and a foreign language credit, but no one listens to me. So again, if this is helpful, the eighth thing, use it. If it's not, forget I ever said it and just memorize each of them individually. That's fine. So here's another thing that may or may not be useful. There's one category, there's 4 polyatomic ions in here that look very, very similar. Actually down here at the bottom, perchlorate, chlorate, chlorite, and hypochlorite. So the chlorate-chlorite connection we've already talked about. Chlorate has 3 oxygens, so chlorite has 2. Then we see like there's this other version, there's perchlorate. So if there's a per in front, it has 1 more oxygen. So chlorate has 3 oxygens, so perchlorate has 4 oxygens. If it starts with a hypo, like there's chlorite and then there's hypochlorite, we take 1 more oxygen away. It may or may not be useful to actually memorize this. This is the only pattern that you are held responsible for memorizing for the polyatomic ions with this, but there are many other of these, like there's bromate, there's perbromate, bromate, bromite, and hypobromite. If you look on your polyatomic sheet, bromate is the only one that you're supposed to memorize, but there are others, okay? So again, may or may not be helpful. And then this one, again, may or may not be helpful. This is me taking like the periodic table where carbon, nitrogen, phosphorus, sulfur, and chlorine live. So chlorine is in group 17. And if you look at the polyatomic ion list, all the polyatomic ions that contain chlorine are a -1 charge, just like chlorine. When it's an ion, it has a -1 charge. All the polyatomic ions that contain sulfur, sulfate, sulfite, those are all -2 charges, just like sulfur from group 16 is a -2 charge. And all the polyatomic ions that contain phosphorus, phosphate, and phosphite are all 3- charges, just like phosphorus itself has a 3- charge. So phosphate and all the phosphorus things are 3-, sulfate and all the sulfur things are 2-. Perchlorate, chlorate, hypochlorite, chlorite are all -1, just like chlorine is. The other pattern on there is carbonate and nitrate. Carbon is in period row 2, and nitrogen is in row 2, and those have 3 oxygens in their 8 version. The things in period 3, phosphorus, sulfur, and chlorine, all have 4 oxygens in their 8 version. So again, you read this and you're like, this is weird, I don't like it. Then forget it, just memorize them, okay? Pretty much, I think it's the last suggestion I have for you guys on memorizing these. You have some that are, you have a hydrogen version. So like carbonate is one of your polyatomic ions. And then below that is hydrogen carbonate. You've got phosphate, and then you've got hydrogen phosphate, and then you have dihydrogen phosphate. Hydrogen lives in group 1 on the periodic table. So it's got a +1 charge. So if we look at this, if we take carbonate ion and add an H+ to it, we literally get a hydrogen attached to a carbonate. The charge goes from -2 to -1 because the -2 carbonate and the +1 hydrogen add together to get a -1 charge. So the hydrogen whatever is a very literal name. It's taking like the carbonate and adding a hydrogen ion to it, which is where we get the HCO3. Dihydrogen phosphate is taking phosphate and adding 2 H+ to it. This is another table from our textbook that just has a list of common anions. This is not all of them. You were given the polyatomic ion sheet for what you have to memorize. You need to know to name things in group 15, 16, and 17. So real quick, last thing, we're just going to look at a table and fill in either the name or the symbol for any of these ions. So CrO4-2 is a polyatomic ion. So for this one, right now, look at your polyatomic ion sheet. But by our next exam, or first exam, I guess, memorize that CrO4-2 is chromate. And you could either write chromate ion or just chromate. The polyatomic ions, we don't have to write the word ion after them. All right, so the name aluminum ion. Well, that's just an element with a charge. So aluminum, we'd have to know is Al. Then we're going to look on the periodic table. Aluminum lives in group 13. So it's a 3+. Okay, so the next one, we got Br-. So it's an element. Br stands for bromine. It's a negative charge. The negative ones are the ones where we have to drop off the ending and replace it with "ide." So bromine becomes bromide. So bromide ion, you could just write bromide. So I'm going to put highlighter over the word ions that didn't have to be there. Oh, that's fun. Ooh, notice I didn't highlight the one after aluminum. That one has to be there. Okay. So the name hydrogen carbonate ion. This is a polyatomic ion. It's HCO3 minus 1. The word ion is optional in this situation. It could just be called hydrogen carbonate. OH minus is another polyatomic ion, so we would just have to memorize that that one's name is hydroxide, with the word ion being optional. The term or the name sulfide ion is optional. It ends in "ide" and it starts in sulf, so like sulfur, but with a negative charge. So we'd look at sulfur on the periodic table. It's in group 16, so it has a negative 2 charge, 2 minus. Sulfite ion, that's one of our polyatomic ions. It's SO3 negative 2. So just be careful. Those two names have the difference of one letter, but they're different formulas. So just be careful. It's important. Spelling matters here. AU 3+. All right, so AU is gold. So we find gold on the periodic table. We don't know its charge based on where it lives on the periodic table. It's not one of the groups that has a charge. So this is when we have to put parentheses in the name. So it's going to be gold with parentheses and the Roman numeral for 3 that says it's a 3+, and then the word ion. I'm not highlighting the word ion there. The ion there is necessary. Okay. So we will start on, in the next class period, naming compounds.